Thanks to the many advances of science and technology, our lives are getting more and more comfortable each and every day. We drive around in cars instead of riding horses, use air conditioners instead of fans, and use refrigerators instead of harvesting ice. However, because of these and other human activities, temperatures on the Earth are rising, and the ozone layer that has protected us is being destroyed. Today's topic is global warming and the ozone layer. Simply put, global warming is the rise of the average temperatures on the Earth. Due to the increased use of fossil fuels for our cars, as well as for air conditioning and heating systems, more and more greenhouse gases are being emitted into the atmosphere. And these greenhouse gases are causing average temperatures all around the world to rise. Let's talk about how global warming works in greater detail. The complex interactions between water, the atmosphere, the sun, and the moon are what make life on Earth possible. The atmosphere plays an important role in sustaining life through what is known as the greenhouse effect. The Earth on which we live both absorbs and releases energy. The energy absorbed by the Earth is called solar radiation energy, and the energy released by the Earth is called Earth radiation energy. What would happen if the Earth had no atmosphere? If there were no atmosphere, the Earth would radiate as much energy as it absorbs. For every 100 parts solar radiation energy absorbed, there would be 100 parts Earth radiation energy emitted. However, the existence of the Earth's atmosphere changes this balance. Some of the Earth radiation energy is absorbed by the atmosphere and then radiated back down to insulate the surface of the Earth. This is called the greenhouse effect, and this effect has a great impact on global warming. However, it is important to realize that the greenhouse effect and global warming are two different things. The greenhouse effect itself is a good phenomenon that helps the Earth maintain its temperature. However, when this greenhouse effect becomes too great, it has a negative effect, causing global warming. Gases that absorb Earth radiation energy and cause the greenhouse effect are called greenhouse gases. Examples of these gases include water vapor and carbon dioxide. Carbon dioxide and water vapor are mostly produced through the combustion of fossil fuels. We wake up in the morning, take a shower, cook and have our breakfasts, then go to school in a car or a bus. However, all of these actions result in the production and release of carbon dioxide. As our production of carbon dioxide increases, greenhouse gases also naturally increase. The greenhouse effect caused by these greenhouse gases raises the temperatures of the Earth, causing more severe global warming. Global warming is dangerous because it creates a cycle that continues to raise the temperatures of the Earth. We call this vicious cycle the runaway global warming effect. Rising temperatures due to global warming also cause continental glaciers to melt, which causes the sea levels to rise. This causes the flooding of coastal areas and the reduction of land area. When we talk about glaciers, we also need to consider their reflection of solar energy. Reflection refers to how much of the solar radiation absorbed by the Earth is reflected or scattered in the atmosphere or across the Earth's surface. If reflection decreases, absorption increases, resulting in higher air temperatures. Reflection varies by location, depending on the geographical conditions of the Earth's surface. About 10% to 20% of solar radiation is reflected in forests, 35 to 45% in deserts, 50 to 70% on glaciers, and 80 to 90% on snow. This means that when global warming melts glaciers, there is less reflection, which raises air temperatures and accelerates global warming. When sea temperatures rise due to global warming, less carbon dioxide can be dissolved in the water. When the oceans can't dissolve as much carbon dioxide, more carbon dioxide is released into the air, which increases the concentration of carbon dioxide in the atmosphere. This also accelerates global warming. Another thing that contributes to global warming is that as air temperatures increase, more evaporation occurs, which puts more water vapor in the atmosphere. Think of water turning into steam and evaporating out of a kettle. Since water vapor, like carbon dioxide, is a greenhouse gas, it also contributes to global warming. The chain reaction of global warming is an expression used to explain the cycle in which global warming contributes to even more severe global warming. We need to think about what we can do to stop this vicious cycle and stop the damage being done to the Earth by global warming. As we mentioned previously when we discussed the greenhouse effect, the Earth is surrounded by the atmosphere, which stretches up 1,000 kilometers off the ground. The atmosphere is divided by altitude and temperature into the troposphere, stratosphere, mesosphere, and thermosphere. The ozone layer is located in the stratosphere. It is approximately 20 to 30 kilometers from the Earth's surface and has the highest concentrations of ozone in the atmosphere. Thankfully, this ozone layer blocks out harmful ultraviolet radiation in solar radiation to protect life forms like ourselves who live on the Earth's surface. However, artificial compounds used in refrigerators are destroying the ozone layer. Chlorofluorocarbons, CFCs, also known as freon gases, lose their chlorine atom when they reach the stratosphere. These chlorine atoms act as catalysts that destroy ozone molecules. It is said that a single chlorine atom that reaches the stratosphere can stay in the atmosphere for 100 years, destroying some 100,000 ozone molecules. Ozone is naturally created and destroyed, but artificial compounds like CFCs destroy ozone molecules faster than they can be created. If more ozone in the stratosphere is destroyed than created, ozone concentrations drop, potentially forming ozone holes, which are areas of low ozone concentration. Low ozone levels mean that more ultraviolet radiation can reach the surface of the Earth. This increased radiation can cause various problems such as skin cancer, cataracts, genetic mutations, and damage to the immune system for humans and lower photosynthetic activity for plants. There are also problems that can be caused by dropping ozone concentrations in the stratosphere and increasing ozone levels in the troposphere. What do you think the relationship is between these two concentrations? Ozone plays opposite roles in the stratosphere and in the troposphere. As we've already mentioned, ozone in the stratosphere absorbs ultraviolet rays and helps protect life on Earth. However, ozone in the troposphere is created through photochemical reactions caused by ultraviolet rays in nitrogen oxides found in vehicle exhaust gases. Since concentrations of nitrogen oxides are higher near the surface of the Earth, if less ultraviolet rays are absorbed in the stratosphere, these rays react more with nitrogen oxides near the surface and cause higher ozone concentrations in the troposphere. So, what kinds of problems can this cause? If ozone layers in the stratosphere drop, and the stratosphere is unable to trap ultraviolet rays, temperatures in the stratosphere may decrease, leading to climate change. Also, the ultraviolet rays that pass through the stratosphere without being absorbed cause higher ozone layers in the troposphere, closer to the Earth's surface. This can cause respiratory diseases and other problems. Today, we learned about global warming and ozone layer destruction, which is often caused by the technological advancements and developments that make the lives of humans more comfortable. The effects of these terrifying phenomena will only get worse over time. Starting today, we need to consider more carefully how our actions impact the environment around us. Maybe, if we are more concerned about the environment than about our own comfort, we can create a healthier world, which is something that we all need. Our next topic will be the rotation of the Earth and the revolutions of the celestial bodies. Stay tuned for the next lecture in the Why series. Series of Why.